Like the Pythagorean theorem, the sine ratio is very useful in solving problems with right triangles. You can use the sine ratio to find the value of an angle. For example, say you want to build a ramp to your front door, and the door is 4 feet above the ground, and the ramp is planned to be 15 feet long. What you want to know is, what is going to be the angle of the ramp to the ground, angle x? To find the value of angle x, in this example, we can use the sine ratio. We know that the sine of x is equal to the opposite over the hypotenuse. The opposite in this case is 4 feet over the hypotenuse, which is 15 feet. Using our calculator, we divide 4 by 15 and we get 0.26666 and so on forever, which rounds off to 0.2667. So the sine of x is equal to 0.2667. Using the calculator again, we can find the inverse sine of x. To find that 0.2667 is equal to 15.5 degrees. So angle x is 15.5 degrees. You can also use the sine ratio to find the measure of a side. For example, say you're building a zip line, and you don't want the zip line to be too steep or riders will go too fast and somebody could get hurt. So let's say that the maximum angle for a zip line is about 3 degrees. And if one end of the zip line is mounted 12 feet above the ground on a pole above a platform, and the other end to another pole that's 5 feet high, how long will the zip line be? And how far apart will the poles be? So looking at our diagram here, we can see that what we're working with is actually a right triangle. And the angle of this angle here is going to be 3 degrees. The opposite side here is 7 feet because that's the difference in the height of the poles. So we can use the sine ratio to find the length of the zip line, which is the hypotenuse. So we know that sine is equal to the opposite over the hypotenuse. So in this example, it's the sine of 3 degrees equals 7 feet over the hypotenuse. Using the sine function on a scientific calculator, we find that the sine of 3 degrees is equal to 0.0523, and we know the opposite is 7 over the hypotenuse. Working with a formula like this one, I always like to use the formula triangle, so we know that sine is equal to the opposite over the hypotenuse. So that means that the hypotenuse is going to be equal to the opposite over the sine. So we've got 7, 0.0523 is going to be equal to the hypotenuse. So when we use our calculator to divide this, we'll divide 7 by 0.0523, and we'll find that the length of the zip line, or the hypotenuse, is 133.8 feet. So the length of our zip line here is 133.8 feet. So now that we have the hypotenuse, we have 2 sides of the right triangle, and we can just use the Pythagorean theorem to find the length of the third side, is the distance between the poles. So this is an example of how you can use trigonometry to solve real-world problems with triangles.